In this lesson, we'll continue to discuss drainage terms.
Even though we don't install clay tile cylinders anymore, we often still refer to it as tile pipe. Technically, it's subsurface drainage corrugated plastic, single wall corrugated plastic drain pipe is what we would say. But like you see on the slide, tile pipe. Common sizes are 3-inch, which is the very smallest one shown in the picture, 4-inch, 6-inch, 8-inch, 10, 12-inch diameter. We refer to tile pipe in terms of its diameter. And I do want to note that smaller pipes are increasingly common. For example, 3-inch diameter, which isn't listed on the screen, but it is the smallest one shown there. Rather than placing clay cylinders abutted together in a hand-dug trench like the old days, our drainage pipe is installed in long rolls, like you see shown in this picture here. One nuance that you may not know unless you're looking very closely at a drain pipe, a corrugated plastic drain pipe, is that it has small slits. These are called perforations. And so we have drain pipe that's perforated, like what is shown here. That's how water actually gets into the pipe when it's underground. These perforations, these holes, that's how water gets in and then flows out of the pipe. We also have non-perforated or solid drain pipe. There's sometimes when you need solid pipe where you don't want water to be entering the pipe, you just want to convey the water underground. So we have solid pipe that looks exactly the same, it just doesn't have those perforations or those holes in it. And it comes in the same size diameters. And then another nuance is that drain companies make what's called single wall, which is shown on the left, versus dual wall, which is shown on the right. Dual wall tends to come in larger diameter sizes and is exactly what you would think. It has two walls inside. It has the outside wall and then the inside wall. The inside wall is a smoother surface. So this is going to matter when we talk about surface roughness of the pipe in one of the upcoming lessons when we're talking about Manning's equation. The surface roughness that the water touches going down the pipe, that matters for how water is conveyed. Dual wall is typically, like I mentioned, the larger pipe sizes, and it provides a little extra rigidity for such a large pipe. There's a variety of fittings, just like any plumbing system. This just happens to be underground plumbing, so you have T's where you can connect two pipes in a T shape. You can use a Y to connect it in a Y shape. There's reducers if you're going from small pipe up to larger pipe. So there's a variety of fittings that tile pipe companies make. And the other thing I want to cover in this lesson is that there are parts and pieces for special situations in terms of drainage. And here, I mean, these are parts that are used in specific situations or specific instances that might not be everywhere. Starting with a pumped outlet. Pumped outlets are not something we have a whole lot of here in Illinois, but the situation here is that the grade or the slope of the drainage pipe in the field or the main leaving the field is such that it would never outlet. So you can see the bottom of the ditch here, and you can see where the pipe is in the field. So that pipe would never daylight. It's too low in terms of its elevation. The main tile ends up being below the elevation of the bottom of the ditch. So essentially the pipe would never daylight, and so you need what's called a pumped outlet. A pumped outlet is where the outlet of the subsurface drainage system comes out into a big sump or a big tub, and then a pump pumps the water up and over into the ditch. Remember, subsurface drainage systems are all gravity flow. There's no pumps out there in the middle of the field. So you have to have your grade right for the tile pipe in the field. All the laterals and the main in the field has to be graded so that it'll flow by gravity. But then if you end up in a situation where that outlet of the pipe is too low, you'll need to pump it up and over. This does add significant cost to the drainage system, and these are typically used in very, very flat areas where the land has little grade, especially if deep ditches haven't already been dug. We're fortunate in Illinois to have a lot of very deep ditches that were hand dug a century ago or dug with a lot of labor a century ago. The pumped outlet is very common in places like the Red River Valley in the eastern Dakotas and western Minnesota, where my in-laws happen to live. Another special part is a surface inlet or a surface intake, or what's also called a surface riser. You see these driving around. Here in East Central Illinois, And this is typically one of the only parts of a subsurface drainage system that you'll ever see, because everything else is underground. A surface inlet or intake is essentially a direct connection to the subsurface drainage system. They're important agronomically because they drain kind of the worst places in the field, the ponded areas, the lowest parts of the field that hold a lot of water. So agronomically they're important because they allow a lot of water to leave the field, a lot of surface water to leave the field very quickly. Environmentally, they're important because they're one of the main ways that sediment can enter our tile drainage system. Tile drainage water tends to be very clear with not a lot of sediment in it, but if you have a surface intake or a surface riser, it's again a direct connection right down to the drainage system. The next kind of special drainage system is a terrace tile. Most of you will know what a terrace is. In hillier landscapes, terraces are used to prevent soil erosion going down the slope of a cultivated field. If you divide that up into terraces, then you'll slow your soil erosion, prevent erosion. Sometimes the terraces hold water. So you could see if this was sloped right here towards the terrace, there's a lip. And so you don't want that to hold water because you're trying to crop that area. That's where a terrace tile comes in. Terrace tile is a surface intake and associated subsurface drainage system to drain that terrace. This is one of the few examples when we install drain pipes, subsurface drain pipes on hillier terrain. The majority of drain pipes go in where it's really flat because there's no natural surface drainage. A surface intake can be used to drain the terrace, which helps prevent soil erosion. So there's a trade-off here, of tile drainage systems carrying nitrate, but also being used, especially in this case, to reduce erosion. The next kind of special part is a control structure. This is the image courtesy of AgriDrain. So the control structure can be installed over a drain pipe, which includes plates, also called gates or stop logs, which I'm showing here. These gates or stop logs can be inserted to hold back water behind the plates, thus managing the elevation of the outlet. So this is kind of like a manhole that goes all the way down to your drain pipe underground. In our group, we use these control structures as a part of our monitoring system. Like I said, they're kind of a manhole that allow you access down to the drain pipe. It's not big enough to climb down in, but you can at least grab a water sample or put your auto sampler tube all the way down to that depth of the tile. And then control structures are also a critical part of several of our conservation practices that we'll talk about, like bioreactors, saturated buffers, and the practice of controlled drainage. And then our last special part that I just want to illustrate, a tile probe, is a hand tool consisting of a rod with a T that you literally poke in the ground to try to find where you hit a clay tile. Remember, many old clay tiles have been in the ground for feasibly 150 years. And so in many cases, in many fields, using a tile probe to literally try to poke and see where the tile is, that's the only way to find it. Not an easy job, not a pleasant job, but tile probes are used often. That's it. See you next time.